Okay, we're going to work on the quiz for the second half of Chapter 11. We're going to do 2 quizzes combined because you only have to go, well, we're going to go through 2 quizzes combined here. All right, looking on page 761. Okay, looking on page 761, let's change color here. Okay, number 1, find the length of AB. Now you should have your theorem list out in front of you so you can remember these equations. It says find the indicated measure, the length of AB. Now length is going to be a distance that goes around there, not a degree. So the first thing you're going to have to do is find the circumference of the whole circle so that you know the distance around the whole circle. And since we have a diameter of 14 meters, we're going to say circumference is equal to pi times diameter, or 3.14 times 14. And using your calculator, you can use 3.14 or the pi button, but recognize that your answers might be slightly different. So 43.96, or we're going to say 44 because we're going to round to the nearest tenth. Generally that's what you need to round to. So circumference is about 44. I guess I should make this approximately. That's a wavy equal sign. Okay, now the part that they're talking about for AB is 78 degrees, which is also the central angle, by the way. And so they only want 78 degrees out of the entire 360 of circumference. So to figure out just AB, you're going to say, well then I want 78 degrees out of 360 degrees of, which is always times, that 44. Okay, so on your calculator you're just going to key in 78, and a fraction is always division, 360, 78 divided by 360, and you can either press the equal sign there or not, and then multiply that times 44. And you're going to get 9.5. Okay, now they've taken it out to the hundredths in all of these cases in the book, but normally they tell you to take it to the tenth. So it would be 9.5 if we had left 44 as 43.96, then we would have had 9.53 right there. Okay, the details of that, I mean, if they tell you specifically to go out to the tenths or the 100ths, that's an issue. If they don't tell you, then if you are off by a tenth, that's fine. Okay, circumference of circle F. You're going to find the circumference of circle F, and you know just this part that is 36 inches, I'm sorry, which is 102. So we know that 102, the fraction of 102 out of 360 degrees of the circumference is equal to that 36 inches that we see there. Okay, so when you write it out this way, we know that it's 102 out of 360 times C is 36 inches. And some people will want to just make that into a decimal. So let's go ahead and do that. 102 divided by 360 is the decimal. 0.2833. And that's 3 repeating, of the circumference is 36 inches, and then they'll want to divide by 0.283, repeating, to find the circumference. Okay, now on the TI-83 or TI-84, remember, you can say 36 divided by second A and S, and it will use that previous answer, and you get circumference is equal to 127.058. So that's going to be 06 when we round it to the nearest hundredth. Again, it doesn't tell you where you have to round it to, so if you had rounded it to the nearest tenth, that would have been acceptable as well. Just want to make sure that you were able to see the very bottom, which almost you're not. So let me back this off just a little bit, or tilt it down just just a little bit so you can see better what I'm doing. Okay, so let's go on to number 3. You're to find the radius here. Okay, so that means if we can find the circumference first, then we can use our circumference equation to find the radius by dividing by pi. So we have a 65-degree central angle here. It's very important for you to remember that that also makes the arc 65 degrees because it's a central angle. There are 2 different kinds of angles we dealt with here. One of them was the inscribed angle, which is half of that distance. But you're looking at a central angle, which is equal to the arc. So 65 degrees out of 360 of the circumference is equal to 29 feet. Okay, that's how you're going to find out what the actual circumference of that circle is. Okay, now most of you will just want to divide 65 by 360 to get the decimal, and we get 0.1805, and if we're going to round to the nearest hundredths place, we would leave that 1/8. 0.18 of the circumference was 29 feet here, because this was that fraction of the whole circumference. And then we're going to divide 29, and again you can say 29 divided by second answer if you've got the TI 83 or 84, and you will get, 29 divided by I lost mine, so 1805, if I want to go out that far, is equal to 160. And it's good to do a reality check and ask yourself, 160.1 is about what the circumference is. I really should be making these approximates. Okay, approximately 160.1. Now we're going to use our circumference to find the diameter. Since circumference equals pi times d, we're going to say our circumference is 160.1 times pi d, and if we divide both sides by pi, we will get the diameter. Okay, 160.1 divided by 3.14, or use your pi key, and we get diameter is about 51. Even if we round this to the nearest, well, hundredth, I guess would be 50.99. Okay, and then we can just press divide by 2, and you've got all that decimal junk out there, that's okay too, and we get 25.5. So, we divided by 2 because 2 radii make a diameter, and we get 25.49. Okay, in my book I have 25.56 feet, and that's probably because they use the pi key and we use 3.14. Or because they cleared calculator at some point. Not a big deal, close enough. Okay, and as long as I can see your work and I can see what you're doing, you're fine. Alright, moving on to number 4. Find the area of the shaded region. Okay, to find the shaded region, we're going to have to take the entire area of the circle and subtract the small circle from it. So we're going to be using the area of a circle is pi r squared, and we have our radii here. The radius of the big circle is 33 meters, and the radius of the small circle is just 11. I'm going to need to make this a little bit smaller, I think. Okay, so since area equals pi, or 3.14, times 33 squared. Now if you're, you want to make sure that you square 33 before you multiply 3.14 times that. So 33 squared times 3.14. Now you can hit the equal sign in between if you like. It's not going to make a difference. Okay, the entire area of the large circle is 3,419.4. Okay, but that's the area of the large circle. And if you label your stuff, it's much easier to find what you're looking for later on. Now we're going to do the area of the small, and that will also be pi r squared. So that's pi times 11 squared. So we do 11 squared times pi, and that's 379.94. Now all we have to do is subtract the two. And we get 3,039.52. Okay, now you may have gotten, if you use the pi key, about 3,041.06, and this is in meters squared. I really should be putting that down. This is in meters squared. Alright, looking at number 5, and I'm going to erase what I've done before. Remember, you can roll these back at any time. Now we're going to be using sectors in the same way that we did for our arcs. The number of degrees over 360 that you're talking about would be the fraction that you're dealing with of the entire circle, but this time we're going to do it with area. Now we have our radius right here, so we're going to say area is equal to pi r squared, and r in this case is 8.7. Don't let decimals bother you. You have a calculator. Don't let fractions bother you. Just use your calculator to convert them to decimals. Make sure that you show me everything that you're doing so that if you make a mistake, I can give you credit. So we have 8.7 squared times, and we're just going to use the pi button this time. For those of you who like that pi button. Okay, and we have 200. The area is equal to 237. So we're going to put inches squared. Now we're going to look at the shaded part and ask how much of that area are we talking about? Well, we have 63 degrees here and 63 degrees here. So we're going to add those two together. 63 and 63 is going to be 126. And so the part that's shaded is 126 degrees out of the entire thing. So we don't have to subtract in this case because we know the fraction that is shaded. So we're going to say 126 degrees out of 360. That's the fraction part that we're looking for of the total area. And what is that total area? It's down here, 237, 7.79. Okay, so we're just going to divide 126 divided by 360, and then we're going to multiply that times 237.79 because that's the part we're wanting to know. And that is equal to approximately 83.23. Now, as you've been working through your book, you probably noticed that early on they were using 3.14 as pi, and now they're using the pi key. I'm noticing more and more as we were doing some comparison. Alright, now we're going to look at this. This is going to cause us to have to go back to a previous chapter and remember how to find the area of a rhombus. Okay, which is 1/2 diameter 1 times diameter 2. Not diameter, I'm sorry. 1/2 diagonal 1 times diagonal 2. Okay, so first let's find the area of the circle. We're going to do this right over here to the side so we can see what we're doing. Okay, so looking at this circle, if the entire diameter is 6 centimeters, that makes this one 3. Just the radius is 3. And we need the radius for area because area is equal to pi r squared, or 3 squared times pi. So 3 squared times pi equals 28. So we're going to say approximately 28.27 is the whole circle. Alright, now we're going to look a little bit more carefully at the diamond in it. I'm going to erase this so that we can see what we're looking at. Remember, the area of a diamond is 1/2. I guess I should put up here that this is the circle. Okay, is 1/2 diagonal 1 times diagonal 2. And so we need both diagonals in here. Well, this diagonal is the same as the diameter, so it's 6. Now, these hatch marks are showing us that this other segment is divided into 4 equal parts. And 6 divided by 4 would be 1/2. But we have 2 of the 1/2, so that gives us the smaller diagonal to be 3. So we're going to say 1/2 of 6 times 3. Well, 6 times 3 is 18, and half of that would be 9. Okay, now we're going to have to subtract that part out because it's not the shaded part. So we say 28.274 minus 9 is equal to 19.27 approximately, I guess I should say. So the area of the shaded is approximately, and I'll go ahead and write this, 19.27, and that's in centimeters squared. Always go back and check to make sure you've put in your units. Okay, now we're going to, on page 777, we're going to go through 1 and